Hi everyone, welcome to our webinar today. The topic of this webinar is Procurement Guidance for Energy Storage Projects, Help with RFIs, RFQs, and RFPs. And our host for this webinar is Todd Olinsky-Paul. Todd is a project director with Clean Energy Group and the Clean Energy States Alliance. And before I pass this over to Todd to talk a bit more about this webinar, I'd like to go over a few quick housekeeping notes. All of our participants for this webinar are in listen-only mode, so you have a couple of options to join the audio portion of this webinar. You can either call in using your computer mic and speakers, or you can connect using your telephone, and there are some instructions on your screen for doing that. Very important note, we ask that you please submit your questions as you think of them throughout the webinar by typing them into the question box on your webinar console and hitting send. And we will make sure to save a lot of time for Q&A after our presentations, but don't wait until the end to submit your question. It just decreases the chance that we will get to it. So please type it in as you think of it. Finally, this webinar is being recorded. You will find a recording of this webinar as well as all of our previous webinars on our website at cesa.org/webinars, and we'll also send you a follow-up email for those of you attending live with a link to that webinar recording and to the slides. And with that, I'd like to pass it over to Todd Olinsky-Paul, who is our host for this webinar.
Okay, thanks very much, Samantha. Welcome everybody to the webinar. This is an ESTAP webinar, and if you could advance the slide, please. It's a little different from our normal ESTAP webinars in that this one is really going to be much more focused on answering questions from attendees and trying to, engage in discussion and address issues that you raise. So we will do a little brief intro and present some material, but we really want to try to leave plenty of time to get to all the questions, or at least all the relevant non-redundant questions that we can. Also, we are going to be the material we're presenting here today is not in its final form. What we actually want to do is to improve it by making sure that we take into account and address the questions and issues that are raised by those of you who are attending during this webinar, and then we'll send it out to you. We're also going to attach a couple of model RFPs for use in developing RFPs for energy storage projects. And so you'll get that packet if you're registered, and for the webinar you'll get that packet probably sometime in the following week or two once we have a chance to put it all together. So even if we don't get to your question during the webinar, we will have a chance to incorporate it into those materials, and it'll be addressed in the packet that you'll get. So I want to encourage everyone, as Samantha said, to go ahead and ask questions as you think of them, so we can make sure that we get to as many as possible. Before I go on and introduce our presenters for today, I want to say thank you to Dr. Imre Zsuk at the U.S. Department of Energy, Office of Electricity Delivery and Energy Reliability, who sponsors our energy storage program, and to Dan Borneo from Sandia National Laboratories, who we have a contract with Sandia, and that's how we're able to do this work. And Dan is with us today, so he will be speaking in just a minute. If you could please advance the slide. I'm going to give a little bit of background about the ESTAP program. ESTAP is a project of CESA, which is Clean Energy States Alliance. We're a nonprofit located in Vermont, and we are engaged in this work through a contract with Sandia National Laboratories, and we work in and with states all over the country to support their efforts to develop energy storage projects, policy, and programs. And you could see on the map, it's a little hard to read because it's small, but we're really working all over the map with states. And our primary role is to bring state entities and municipal entities to the table to partner with U.S. DOE Office of Electricity and with Sandia National Laboratories to develop energy storage demonstration projects. So that's what we do, and if you could just advance to the next slide, please. This particular webinar is really as a result of Sandia and DOE supporting through CESA and also with our sort of parent organization, Clean Energy Group, supporting Massachusetts Department of Energy Resources, DOER, in its work in Massachusetts. DOER made a significant investment in resilient power projects over the past couple of years. There's a number of those projects in Massachusetts that are being developed and incorporating energy storage technologies. And so the thinking going into this, developing this webinar, was that since we've gotten a lot of requests from those municipalities that are developing those projects for help in putting together RFPs, RFQs, RFIs, and other solicitation documents related to energy storage, that we should do a webinar to just go over some of the elements of those documents and what you should include and what you should expect to get in the way of information from applicants, so that the object being that the municipality or whoever's developing the project gets good information and is able to make the best choices in terms of who they end up contracting with for these projects. So having said that, I just want to note that this webinar, as with all of our webinars, is being recorded and it will be archived on our website. You can see on the screenshot here on the left-hand column there's a red arrow pointing to the menu item that says ESTAP Webinars. That's where you would go if you wanted to review one of our webinars at any time. They're there in their entirety and also as slide decks, so if you just want to view the slides you could do that too. And there's a big red circle around the button that you could push if you wanted to subscribe to our email list and be notified of future webinars. So that's, and then there's all kinds of other resources on that site if you want to check that out, upcoming events, news, resources, reports, and so forth. Next slide, please. There's a little delay here. Okay, thank you. I should mention as well, I did mention the Clean Energy Group earlier. We have something called the Resilient Power Project, which is foundation funded, which is also engaged in this work supporting these Massachusetts projects, and also has produced a number of reports that are available on the Clean Energy Group website. Next slide, please. And I think we have a screenshot of that. There you go. And so to find that, you would go to www.resilient-power.org, and all those materials will be there. Next slide, please. So at this point, I would like to introduce our speakers, and then they're going to briefly introduce their organizations. We have Dan Borneo, a senior electrical engineer at Sandia National Laboratories in the Distributed Energy Electrical Energy Storage Program. Dan's been involved in the electrical industry for 30 years. He works in distributed energy electrical energy storage at Sandia and works with industry in bringing innovative electrical energy storage technologies to commercialization. His prior work was in building and maintaining electrical infrastructure in the semiconductor industry. He holds a BSEE and MSEE from University of New Mexico. We're also joined by Nick Turchak, an energy engineer at Bright Power. Nick is a software product and sustainability enthusiast originally from Kiev, Ukraine. He holds a telecom engineering degree from National Aviation University in Kiev and a sustainability management MS from Columbia University. Before transitioning his career to building energy, Nick's background was in building complex software services and solutions for the digital media industry. Throughout his career, Nick has been exposed to various software ecosystems, technological stacks, paradigms, and processes, and has led the development and deployment of several large projects with strict availability SLAs. So those are our presenters. I think at this point I'm going to hand this over to Dan Borneo to say a few words about Sandia and its energy storage programs, and then we'll go to Nick for a few words about his company, Bright Power. So Dan, over to you.
Thank you, Todd. Good morning. My name is Dan Borneo with Sandia National Laboratories. And so just so we get to the meat of the webinar, I'm going to go quickly over our introduction. Next slide, Sam. So we're funded through the DOE Office of Electricity, led by Dr. Emery Zhook. At Sandia, in our energy storage group, we basically look at 5 or so areas, one being materials, power electronics, the demonstrations and testing, and grid analytics, policy, and outreach, which is part of this. And involved in all of those is safety, which is becoming more and more prevalent with us and our work. So I lead the systems demonstration and testing. So what we do is basically, next slide, Sam, is basically we're working with industry and with the states and with everybody, both nationally and internationally, that would like to get our technical support as they go and try to develop projects, develop the analysis for the projects, and to proliferate the use of energy storage in a safe and reliable manner. So you can see all our bullets there, and I won't bother to go through those, but basically we're the government tax dollars at work trying to help the industry move forward in energy storage development and implementation. So I'm going to stop there, and I will hand it back to Todd.
Okay, and I'm going to pass it right over to Nick so he can do a little intro of Bright Power, and then we will kick off the actual presentation. So Nick, if you're ready to go, please go ahead.
Hello. My name is Nick Turchak, and I am with Bright Power. We are a mid-sized private energy management firm based in Manhattan, New York City. And the company is 11 years old, and it provides services mostly to large national multifamily portfolios of large residential buildings. Next slide, please. So yes, so this is our suite of services. And I am specifically working in the on-site generation group of the engineering team, and we help clients install renewable energy and on-site generation, and that can provide them with resiliency that in New York City after Hurricane Sandy is very much on the map. Next slide, please. So let me speak really briefly about what we mean when we say new type of resiliency. Traditional resiliency involves standby gas generators mostly, and any building more than 8 floors is actually required by code in the city to have some sort of backup generation. So one of the projects we are involved with in this year, funded by New York State Energy Research and Development Authority, is actually enabling an existing solar array at one of the buildings in the Bronx to create a microgrid and power some critical loads that the existing generator at that building does not power. Next slide, please. And again, so you get the context, we are involved in what's called behind-the-meter energy storage projects, so the projects that utility has no control over and that are managed by the building or whoever the building is giving the control to. And right now the technology is there to implement those projects. Next slide, please. So one of the most lucrative opportunities to save money using energy storage is what's called peak shaving or demand charge management, because most large consumers pay a demand charge that is defined by either 15 or 30-minute interval in a month where they consume the most, and battery storage, if controlled appropriately, can, so to speak, shave that demand. Next slide, please. So, and this is a kind of a typical building block that of a commercially available solution from a company called Demand Energy Networks, and we will be installing it with them in this Bronx project. This is power conversion systems, batteries that specifically are designed to do the demand charge management. But batteries can do much more in the behind-the-meter scenario. In New York, for example, demand response is also a big revenue generation opportunity. So if you can control your batteries to do both demand charge management and demand response, you can get a much better payback for the system. Thank you. That's it.
Okay, great. So thank you both for that little brief intro. We're going to go ahead to the main presentation. This will be a fairly brief presentation, I think. I'm going to ask, what you see on your screen is essentially a table of components of an RFP for an energy storage procurement. And Dan is going to kick off the discussion by going through some of the elements here. We've already got some questions queued up. That's good. As I said, the main point of this is to just use this table as a sort of discussion point to spark some questions that we will then address. So please continue sending those in, and after a little bit of sort of review of this, we will start taking those, and I will read them. Our presenters will answer them, or try to give you some pointers to find answers if that's necessary. And I just want to mention as well that this is open to anybody, but if you happen to be representing a grantee in Massachusetts that has received a DOER resiliency grant, and you are on the webinar and you want to ask a question, just identify yourself as such when you ask the question, in the question itself, so that we know and we make sure that we get to your question. Okay, so I'm going to now turn this over to Dan Borneo, and take it away.
Okay, thank you, Todd. So I sped through the introduction, but now I'm going to try to slow down a little bit and talk about the RFP process. So a little bit about my history. I do come from construction where RFPs were the norm. And so what I'm finding when we're talking to the projects, like for instance Massachusetts State, and people who want to do projects, is that there seems to be a little bit of they don't quite understand the process, or maybe they don't have the engineering support. So this document is to try to at least help them work through the process of at least what questions they need to have answered or answer, or get the resources to answer those questions. If you look at an RFP from the traditional construction point of view, somebody wants to build something, they develop the need, they develop a design, they develop the specifications of all the equipment that is part of that design. Let's say if they want to build a building, they know how many square foot it needs to be. They know, they have engineers figuring out all the mechanical, the electrical requirements. They develop a construction drawing set, and with all the specifications, all the standards that are needed for the project, and then they put that out for bid, and the contractors bid on it, and off they go the merry way to build it. It seems like it's this energy storage. We're kind of new. There's new players. It's not following the traditional sense. So, but we really need to. And so I'm going to try what I'm going to present tries to bring us back to that traditional sense of how you build a project. So when you do an RFP, basically it's like any business plan. So I'm not coming up with anything new, anything earth-breaking here, earth-shattering. It's just, a business plan. Who, what, where, when, why, how, and how much. You answer those questions for the developer of the RFP, they have to ask those questions, and then who's ever bidding on the project needs to answer those questions. So going through, I'll just briefly touch each line item, and as Todd said, hopefully this would just incite questions from you that then we will then gather and disseminate and then try to make a more complete document, a more complete guideline, if you will, that will help you when you're doing your project. So basically the who, right? The details of who's initiating the project, the organization, what you're all about. This always helps just kind of set the stage. The project description and scope of work and the what area are very important, right? What problem are you trying to solve? And then you need to ask, how will the applicant solve this problem? So you don't want to get into the area where you're telling the applicant how to solve the problem. What you want to do is say, hey, I have a problem. What is your solution? Many times we've seen where somebody says, well, I want a lithium-ion battery, or I want a flow battery, where maybe that might not be the best solution to the problem, but since that's what went out in the RFP, then they're, by law, they only can entertain whatever's in the RFP. And that is, well, we're looking at a flow battery. It's like, wait, I have a better solution over here. So you never want to do the work for the contractor. You basically want them to tell you how best to solve the problem. And then you get to select from the various vendors of who has the best solution. The scope of work should be developed. And this is where I talk about the design. A lot of times, you want to develop your specifications, which I will get to, but the scope of work is what you want done. Who will do what when, and all the information that's listed here, plus information that is not listed here, what your expectations are. So then this is where it gets moving down into the operational specifications. This is where it gets interesting, right? Because a lot of times you're going to wrestle with this. So I would expect that there would be a design firm on board, or an engineering staff that you have access to that's going to help you develop this, right? If you don't have this, and what I'm finding is with the energy storage area, it's kind of new, but it's really not that new. If you think about it, batteries have been around for 150 years, and mostly in the form in this contents, in the form of uninterruptible power supplies. So now basically we're almost taking that type of scenario and we're broadening it to this energy storage system. So rather than a UPS, it's just on standby, it's just there in the case of an emergency if you lose power. Now we're changing the way the energy storage will work. We have bidirectional inverters, rather than just unidirectional, which is what the UPS is. And so this energy storage system is going to take on a multitude of applications, and it's going to do more work than just provide UPS services. So you have to figure out what do I want this system to do? So I'm going to have load data. People are going to want to know, well, what is your load, right? How fast does it need to ramp up to a certain discharge rate? And then you have charge and discharge profiles. So how fast does it ramp up? How long does it need to keep that rate? Then how long can you ramp down? How often do you need to do that? Is it once a year? Is it once a day? So these are all the questions that the bidder is going to ask. And so because now they're on the other side saying, hey, you know, I have a system, you want it to last for so long, but I need to know how you're going to run it, right? And then back to that initial thing, you have a problem statement. So if you know your problem to that detail, cool, you're in. You can figure that out. Sometimes you don't. Now, what we're not talking about here, and I'm going to throw a little curveball, is we're talking about an RFP, but there's also, which is a request for proposal. So sometimes if you find that you can't answer these questions, that you're not even in the right neck of the woods there, what you might want to consider is an RFI, which is a request for information, which basically you're asking providers, hey, tell me what's out there. Tell me I got this problem. So you still need to have a problem statement. But then you get a lot of information from them, and from that information then you can go in and write this RFP. Now we're not talking about the RFI today, but maybe, Todd, and maybe a note that if we get some questions on, hey, we want to learn more about the RFI process, that might be a future webinar. So once again, back to the operational specifications. So this is basically how you want the system to operate. For instance, I've been involved now, probably in the last year, maybe a half a dozen RFPs. And every one of them is different. No two are alike. I really can't take a template and apply it from one to the other. It's kind of frustrating sometimes because you think you have all the questions answered and you don't. So when you write an RFP, believe me, you always want to have a question and answer period somewhere in that process before, from the RFP to the award, so all the real nuts and bolts can be ironed out. But so as much as you can answer these questions, the best. And then so on the bidder side, they should be looking to provide all the information their system can provide, all the specifications, all the ambient temperatures, how's it going to run, how many cycles it will do, at what level, et cetera, right? So all those questions need to be answered. Next slide, Sam. So the system specifications. So you would hope in your problem statement that you know how big of a system that you need. Sometimes you might not, and that's okay. I mean, it is what it is, right? A lot of times it might be based upon your budget is what size you need. And type of energy storage, you'll notice there, if you need to specify it, it's one thing, but it's not recommended. Now, areas where you might want to specify is if you're putting something in a building, in a high-rise building. I know in New York City, people there, the fire department, been on conversations with them. They're really nervous about what technology they're going to put in the high-rise and where they're going to put it. So you may have to limit yourself based on their safety concerns on what type of technology you use. The cycle life of projects, I kind of alluded to that in the operational spec, but once again, it's what temperature is the system going to have to operate in? So what cycle life, how many cycles do you want? When let's say it's going to be a frequency regulation system. That's on one end of the spectrum, where it's going to be partial state of discharge, right? Maybe a 10% delta, but you're going to have thousands of them over a week period, right? Every 4 seconds you're getting a new signal to do something. Or you might have an energy shifting. Well, every night, and this is on the other end, every night at 4 p.m. when the sun goes down and the PV is tapering off, or whatever is tapering off, you have your system come on and basically discharge for how many hours, and then recharge, then it goes off, recharges for the next day. So that's like once a day. Or you might have a contingency operation where you're only doing a demand reduction and you're trying to hit the capacity or the transmission charges, trying to reduce your charges, where you might only want to use the system one time a month, maybe one time a year, just so you reduce your charges. Now, what just a little side note on that is when you're doing that, now the beauty of energy storage is, yeah, I'm going to reduce my demand for that capacity charge or transmission charge, but that's only 12, 13 times a year. What do I do with the battery the other days, the other time? And so how do I get the most out of this battery? Because the last thing you want to do is just have that battery sit there, which is, you know, a little editorial, you know, a little advertisement here. That's the beauty of the energy storage system as opposed to the UPS system, where the UPS system of days past, well, even days present, is it just sits there in standby, always on a trickle charge, waiting for the power to go out, and then it dispatches its energy for the duration that it's designed for, and then hopefully the power is back on. So what we're trying to do, and this kind of is, you know, kind of disclaimer here, but we're trying to make the energy storage system as profitable as possible, because, you know, if you read between the lines of the snake oil salesman, energy storage is still expensive, and so the more you use it, the better the return on your investment. So so the system specification now, the ask is, you know, how will the applicant or the bidder meet all the required system specification? It needs to meet the operational and the system as you best can describe it. Now, on the bidder side, basically they have to tell you what they're providing you, and then that gives you the information you need to compare the different bidders' proposals, and also to compare with what your situation is and what you need. So I'm just looking through my notes here to see if I missed anything. Yes, and so the note I have there is basically sometimes you may get a proposal that's completely off base, completely not even what you're thinking of. For instance, just the other day, not that this would relate to anybody, but just the other day, I saw where there's going to be a demonstration of a rail car system where they have a 3,000-foot rail, and they're going to move trains up and down, and basically when they have excess energy, they will push the trains up an incline of, I think it's 8% incline, and then when they need energy, they're going to let the trains roll down and turn into generators. So so there's all these people out there with all these innovative solutions for energy storage, and so you might end up with something maybe you want to try. I don't know. So and so moving on to the design requirements. Let's see here. So one thing that I'm not seeing in these RFPs is basically a design. And so the design would include, it could be the black box, the energy storage system being a black box, but it's going to be somewhere, right? It's either going to be a pad or it's going to be housed in a building somewhere. You have to have the electrical infrastructure to get that system tied to the grid. That all needs to be designed. You have to have all the relaying in place, all the disconnect switches, the breaker panels, the whole distribution, point of connection, conduit installation, cable and wire installation, the communication, cabling and conduit. If you're building a pad or building a building, you need all that civil work done, all the concrete work done, all the grounding done. So this is a package that, in the traditional sense of the word, an AE firm, architect engineering firm, would put together this package and say, hey, listen, here is the package. Now your black box is sitting here, and then now you will have to provide us shop drawings back to see what you're proposing and see how it will fit into what we're calling this black box on this construction drawing. So I hope I'm not making this difficult. It's really not that difficult. It's just common practice, been around for years. If I am making it difficult, feel free to call me on it and ask questions there, Todd. So moving on. So you got the where. So obviously this is just common knowledge. You know, where do you want to put it? You know, are you going to install it at a substation? Are you going to install it at a house? Or maybe you're open to suggestion as to where it needs to be installed. Maybe you need to have it on a certain node on your grid. All this information should be provided in the RFP. So the project timeline, you know, and the timeline should include the RFP process, the review, the question and answer, the interview, the selection, and what I've seen is none of these things ever meet the schedule. So, you know, always give yourself a little bit of time. As we say in construction, you know, you always have to have a little bit of float in your schedule. And then you just continue on with that schedule all the way out through what you're proposing, when you want the system to operate. You need to have some time in there for the construction, for the commissioning, and for the some final testing, what I call shakedown, to where you actually see how this thing is going to operate with everything else on your system, and then you go into operation. And a lot of times, you know, really the easiest part is the construction part. Getting all the permits in place, getting through all the RFP process, especially if you're a government entity. Man, sometimes I'm just amazed of all the process steps you have to go through before you can sign the contract. Then once the contract is signed, you know, you do have some long lead items, so you got to be aware of all that. And so on the bidder side, they have to make sure everything is known up front, that if you need to get a transformer, you're talking 9 months to maybe a year, long lead time. Even an energy storage system might be 9 months to a year, because these energy storage systems are fairly new. The lithium-ion are a little bit more advanced now. They're a little bit more main street, if you will. And so, but even that, they have to manufacture the batteries. They're not sitting on a shelf somewhere waiting for you to call them to put in the order. So you're going to have to allow that time. And then the construction part actually is probably the shortest duration, putting it all together. That's pretty easy. Then comes commissioning. Does it work? These things are new, so you're going to expect problems. I've been around over 30 years, and I've installed megawatts and megawatts of UPS systems, and they have never worked right out of the box. No system that I ever installed, not just the energy storage system, but any system, ever worked right out of the box. That's why your commissioning program should be robust, and we'll probably end up having a webinar sometime in the future on commissioning and what you need to do there, and then you get into the operation. So it's just to be informed of that process. Next slide, Sam. Okay, so the why. You know, what is the goal of the project? If you can answer that. Now, I'm kind of jumping around here a little bit. I don't know that I'm really following the process, so you'll have to kind of integrate these things and move these things and make your RFP kind of flow nicely. I'm not saying this matrix flows very nice, but you know, we're working on it, right? So you want to say, you know, why you're doing it, what's your overall goal of the project, whatever it might be, resiliency, maybe an renewable portfolio standard that you need to meet, you're trying to save money, whatever it is you're trying to do. The more information you provide the bidder, then the better for the bidder to answer the question of how their project provides a solution to your problem. So it's like a give and take, right? Sometimes, though, I find that the more information that you give is not always a good thing, so your information needs to be clear and concise. Sometimes I see RFPs that are 20 pages long, and basically it's 3 pages, but they keep repeating themselves over the next 17 pages. So try to avoid that just for simplicity's sake. So and then on the how, how do you envision this project being put together from your point of view, not from the bidder's point of view, but from your point of view? How will you select the bidder? You should have a grading system, right? This is what we're looking for. This is our criteria of how we're going to select the winner. And then you should have a point system for that. 20 points for prior experience, X amount of points for a safety record, or X amount of points for how long you've been in the business. So whatever it is, whatever you feel your selection criteria, what's important in that selection criteria is that you put the weighted points, and then this way everybody is judged apples to apples as best as you can be. So then in the next item, how much? This is one of my favorites. So I provide a work breakdown structure worksheet, and I try to put it in such a way that when we're comparing the bids, that everybody, you can compare and you can see. Like, I've seen things that it just amazes you, like the price differences. And so you get this WBS, and you line it up, and you think, okay, everybody fill in the blanks. But what you get back, this is crazy, but what you get back is somebody says it's lumped in there. It's in there. So they have zeros in half of the form, and then they give you one lump sum. And you don't know if they're missing anything. You don't know really what's involved in their bid. So when you do this WBS, and actually I have the template of the WBS that we've been putting out for some RFPs we're working on. And it's by no means complete. Every time I do it, I find things that I've missed, so I have to keep adding. Next thing you know, it's going to be a 20-page document. But the important thing to take away from this is you want your bidders to bid to that. You want them to put a dollar item into each line there, so you can see what it is. And if they're missing, and that's the biggest thing, is what are you missing, right? Because if somebody gives you just a lump sum, then you don't really know, like, did they capture everything? Didn't they capture everything? And then sometimes you might find actually that there are bidders out there that are buying projects. I hate to say this, but somebody needs the work, so they're gonna lowball the bid and they're gonna buy the project, or maybe they're gonna provide you a battery, right? That is maybe there's different. Let's say you're going to buy a lithium-ion battery. So not all lithium-ion batteries are created equal. And even if you get a phosphate lithium-ion battery, different manufacturers, different success levels. So when you do this and you start seeing, well, wait a minute, they're just getting some knockoff, some second-rate battery, or no, they're getting it from a bona fide, reputable lithium-ion battery manufacturer. And so this kind of helps you, and also with the specifications when the bidder is providing you what battery they're using and who the manufacturer is. And you want to kind of drive them to that, because what you'll see is a lot of times bidders will just say, I'm going to provide you a lithium iron phosphate battery, but they don't tell you who. You say, well, who? And they say, well, we don't know yet, because if we win the bid, then we're going to go to bid. So there's like this catch-22, and you have to, every project's different. You have to kind of work through that and to see, but what you're trying to do is making sure that What you don't want to do, I guess, is to say is you don't maybe want to take the lowest bidder. You want to take the best proposal, and you want to make sure you're getting quality items. And through your specifications, through your WBS, this is how you get to that. So the boilerplate. Well, the boilerplate is going to be different for everybody. Every state entity, every entity has their own rules and regulations that need to be followed and how the bidders will bid. So all that stuff needs to be included in there. And then for the bidder, you need to provide all that information. And there, we're talking about the warranty information, which should have been specified in the RFP, what type of warranty we're looking for. The bidder needs to provide their warranty, what's in, what's out, all the assumptions. And that's one thing I did not say, and I'm going to take a second here to to make this comment. When you're for the bidders out there, you need to list your assumptions. You need to tell the initiator, you're providing this bid, but these are the assumptions you're making, whether they're, I'm assuming you're going to do this, I'm assuming you're going to do that, I'm assuming that I'm not going to have to do something, I'm assuming that this is covered, I'm not assuming this. So you need to make all these assumptions known up front, and that really just helps clarify the process, clarify the contract. And one of my sayings is the first step in litigation is a contract. So sometimes, the best laid contract leaves many things unanswered, and it comes down to the reputation of the bidder, and it comes down to the initiator being honest and forthright and with what they're asking for. So there is a handshake involved, but unfortunately we do not live in a handshake society anymore. We live in a litigious society, so the contract is important. So the more things you can get laid out and laid to rest in the contract, the better off you're going to be. Next slide, Sam. So that's it. So, Todd, I hope you have a lot of questions.
We do have questions. Thank you very much, Dan. And so we have a number of questions. We're going to hopefully get to all of them. This is really the point of this exercise. And for those of you who have asked if the slides will be available following the webinar or how to get them, the slides are essentially the table that Dan just walked through. We're going to use your questions to help us understand what's missing, what we need to do to improve that table, and we will be sending it out to everyone who's registered, along with some model RFPs. And so yes, you will get that. So Dan and Nick will attempt to address these questions, guys. Some of them may be for one or the other of you. Nick tends to do more smaller behind-the-meter systems, and Dan tends to do more of the larger sort of utility scale stuff. But either of them can probably jump in on any of these. So first question, and this is kind of involved, so we may have to take it a few step at a time. The question is, for a 20 megawatt battery storage plant, can you discuss the following RFP elements? Storage capacity megawatt hours, max discharge rate in nameplate 20 megawatts, hours of discharge at max rate, max charge rate megawatts, output-input cycle efficiency in a percentage. All right, so that's, I think, 5 different things. So let's go back. For 20 megawatt storage plant, could you discuss the RFP element for storage capacity megawatt hours? So let's start with that. And then
so the megawatt hours would be for your application. So the application, if it's let's say it's a frequency regulation application, that might be 15 minutes. So it would be a 5 megawatt hour system. However, if you want to do, let's say, energy shifting, well, that might be a 4-hour system. So that might be 20 megawatts. That would be an 80 megawatt hour system. So what you'll have to do is in your design process and in your analysis process, you figure out what applications are you trying to serve, and then that will dictate both the size in megawatts and the duration in megawatt hours.
Okay. So then the next piece of this question was the maximum discharge rate for nameplate 20 megawatt system.
So yeah, that would also, you know, I hate to use this word, but that would also depend. So if let's say you're having this 20 megawatt system, and you have some spinning reserve that needs to come online, right? So you're going to say, because these batteries can pretty much go full bore. They can put out, depending on the battery, you can put out 100% rated output almost instantaneously, right? And so, but then you would need it. Let's say you have spinning reserve that needs to come online. Well, then you would take full output, and then you would back it off as your spinning reserve comes up to speed. So you would have to do that math to figure out, you know, well, my spinning reserve is going to come on so many megawatts per minute, so my battery could back off there, right? And so on the other end, let's say you're trying to do a renewable smoothing. Well, you would then have to look at this load profile, right? And you'd have to look at your PV profile. And then from there, you would have to decide your ramp rate. Because if you have a big PV farm, let's say you're 20 megawatts. If you're trying to support maybe a 50 megawatt PV farm, well, your PV is what the studies are showing is PV is not going to go away instantaneous. If you had one PV panel, you know, 200 watt, yes, it's going to go away instantaneous. But if you're going over a 10-acre area and there's a cloud coming over, well, it's not going to go over that whole 10-acre area at one time. So what's going to happen is you're going to have a falling off of your PV. There's going to be a ramp rate associated with that, and then your energy storage would just have to meet that ramp rate. But like I said earlier, you know, these energy storage is basically instantaneous. You tell it to come on. The biggest limiter is your electronics, your power electronics, and the communication signal from you saying, I need you, and then it goes through, you know, you might be saying, I need you from an operations center, you know, 10 miles away, and so there's going to be a delay propagating throughout the system until the battery says, or the power electronics said, boom, go on, I'm on it, start discharging. So those are the delays you have to work with. But as far as the battery goes, I mean, if you're right there and you say go, it's not like a generator where it has to come up to speed. It's going to slowly pick up load.
Okay. We got a few more on this one question. I don't want to spend the whole time on one question, but so we talked about storage capacity in megawatt hours. We talked about max discharge rate. The next one was hours of discharge at the maximum rate.
Yeah. So once again, it's based on your application. I think I answered that in one of the previous answers.
Okay. And then there was the max charge rate and the input-output cycle efficiency as a percentage.
I don't know really. So that would be in the specifications provided by the vendor. You could ask, so if you want it on the efficiency part of it, you could ask for an efficiency. For instance, flow batteries are around the 70% range. like lithium ion somewhere in the 90% range, depending on the system. So you could ask for an efficiency that you want out of the system, or if that's germane to your project, or you could just say, hey, you need to provide us the efficiency of your system.
Okay, so going back to what you said before about stating the problem and letting the bidders come up with their best proposal for a solution. So for all this stuff, when as someone who's developing an RFP, do you state we want X amount of storage capacity and discharge rate and Y amount of cycle efficiency, versus just saying, we got to keep X amount of load, online for Y hours, under these circumstances. So how do you determine how specific to get or how non-specific to get?
So if you're looking at, I'm a big advocate of doing an analysis. So in some of the projects we're associated with, Todd, we're doing the analysis, and when you're doing the analysis on like what is your node information, what is your load, for instance, the one utility we're working with, they're basically doing PV, so we're looking at the PV, and also they said we want to do the transmission deferral, and so we're actually looking at that information, right? So we're doing an analysis. Now, one thing is that the labs are we're pretty good at doing this analysis, and hopefully in the future we're going to be transferring some of our knowledge to the architect engineering firms, so then they can start picking this up as part of their design and doing this analysis of what the system is needed. But that's how you do it. You have to kind of get into what is the problem you're trying to solve. For instance, if you're trying to hit a peak demand, right, and so that peak demand is going to happen. So you have the yearly, you have the monthly. So the yearly, the utilities are pretty good at picking, hey, I need it for an hour, right? And then you look, well, what's the probability of me hitting that hour, right? So if I have a 15-minute battery, I'm never going to hit that hour, right? Because it's an hour. I only have 15 minutes. If I have a 1-hour battery, okay, I better be really good at coming on right when I need it and going off right when I need it. However, if I have a 4-hour battery, now the probability of me hitting that 1-hour peak is pretty good, because I can put it on for 2 hours before, and it hits in an hour afterwards. So that there's that probability and how much risk you want to take and how confident you are in your numbers. So does that answer the question, Todd? Should I go more?
No, I think that's good. I want to ask Nick to jump in on this next one. The question is there a rule of thumb for sizing a battery system based on building demand? And I guess this is in the context probably of these of the resiliency projects. Is there a rule of thumb for sizing the system based on building demand?
Well, I don't think there is. One of the things you definitely need to look at is determine demand. Demand could stand for peak demand, the figure that utility charges you for, those 15 or 30 minutes during each month, or it could be average demand. If it's average demand, then depending on which kind of behind-the-meter application, you could use a couple of rules of thumb. If it's peak demand, it doesn't really tell you much because you don't know what the average demand is. So, if that's enough. If you're talking, and again, it's all about the nature of the building and then how it's used. If it's a commercial building or more of a municipal building or a multifamily building, the deviation from its peak to average could be different. If you know the type of building and its average demand, there you could possibly formulate a kind of a rule of thumb. But keep in mind, energy storage systems for peak demand reduction are still in kind of their infancy. So we have been looking at projects, and again, mostly multifamily buildings. So there are a couple of rules of thumb we feel that we could apply, but that might not be applicable for commercial or municipal.
Okay. Somebody wants to know if there are any specific battery technologies that you encourage or discourage, and also what are your opinions on lithium-sulfur batteries?
Lithium-sulfur batteries?
Yep, that's the second part of the question. The first part is, are there any specific battery technology you either encourage or discourage?
So, okay, so I'll start with the second part. I'm not familiar with lithium-sulfur batteries. I might have read something about that. I mean, we got sodium-sulfur, which is, out of NGK, out of Japan. If there is a lithium-sulfur battery, I think it's in the early stages. I'm trying to jog my memory if I just read something recently about a lithium-sulfur trying to mix up the periodic table. But even though I'm not familiar with that. And as far as technologies that you can use, so I hate to say this, but everything you read in energy storage now, lithium-ion has seemed to has taken over the scene, if you will. They make a lot of them. They're high energy density. They're getting to the point now where the cost is coming down because they are really manufacturing them. They're coming out of China. Tesla is building the mega factory in Utah that's going to be pumping out lithium-ion batteries. So they kind of taken over. Now, traditionally, they were power batteries, so that meant that they were like a 15-minute battery. But you'll see more and more of them being installed in energy applications, which is what my definition is, something like in the hour, 2 hour, 3, 4 hour range. Now, the more batteries, the longer you want, the 4 hours. I mean, you're talking buildings now. If you have any quantum, if you have any size, like a megawatt for 4 hours, that's a lot of batteries. If you get into the energy applications, the flow batteries are starting to come onto the scene. The vanadium redox is one that we're working with a lot now, trying to get that into the market. The problem is it's a new technology, so people don't want to really deal with it. So the government, the DOE, we're doing a lot of projects trying to encourage these new technologies and taking some of the burden off by our support, or taking some of the risk away by our support. And so like the vanadium flow battery, that's a 4 hour battery. It could get more, but that's what it's really built for. It's not built for 15 minutes. It's built for 4 hours. And so that's a better application. Then you have the advanced lead acid batteries. East Penn, the Ultra battery, is one that we work closely with. And so that's a lead acid technology, but with they've changed, they mixed up the design of the battery, they mixed up some of the components, adding carbon to it, adding a capacitance to the battery. And those battery, traditionally a lead acid energy battery, as opposed to the lead acid that's underneath the hood of your car, would only go for 300-500 cycles. But with this new, the Ultra battery, the carbon enhanced battery with the capacitor feature, these go 3, 4, 5, 8,000, 10,000 cycles now. So now they're rivaling lithium ion. But once again, they don't have a good market penetration. They're new, so they're having a hard time getting any traction. Sodium sulfur battery is an 8 hour battery. It's a big system. So if you want, they're tried and true. They're in Japan all over the place. There's a few in the States. We have one up in Los Alamos. I'm in Albuquerque, New Mexico. We have one in Los Alamos that we're working with a utility up there, and those are working. They're doing okay. So and then there's this newer stuff that now are just trying to make the inroads. So I'll stop there, Todd.
Okay. Okay. All right. Well, in relation to that question, go ahead, Nick, if you want to jump in.
Yes. I would second Dan on that. There are several interesting technological solutions in the advanced lead acid space. So you are able to see lead acid batteries now that can be discharged almost up to 60%, meaning minimum is at 40% state of charge and up to 4,000 or 5,000 cycles. But those batteries with carbon and capacitance are primarily very low voltage, so you need to install a lot of them. Also, I would note the zinc-based chemistries. Those could be either flow batteries or packaged batteries, and they are typically also on par with vanadium redox 4-hour batteries.
Okay, great. So along the same lines, somebody wants to know, is it good practice to require a specific battery type, for example, lithium-ion, et cetera, in an RFP?
I would not recommend it, because then you're limiting yourself on maybe a better solution by somebody else.
Yeah, I would second that.
Okay. Here's a question about demand peak shaving. In order to be able to value demand peak shaving opportunities, how is it possible to reconcile the availability of the energy storage unit to coincide with the highest 15-minute or 30-minute peak demand interval, specifically associated with ensuring the storage unit is available at that time? So
yes,
if I understand
that's a great question. Yes, so peak demand management behind the meter application mostly. I mean, in the utility scale, you also can shave peaks, but they are much more deterministic. So you peak shave for, let's say, the ISO. You know, in Massachusetts case, it's ISO Northeast. But in the behind the meter type situation, if the only economic opportunity you're tapping with your battery is peak demand reduction, aka peak shaving, you are obviously making sure that the battery is going to be available when that peak hits. And you know, there are pretty sophisticated predictive algorithms that are employed by controller vendors to be able to predict that. But if you are using your battery to do multiple things, such as demand response and peak shaving, it's a very good question. And there are a couple of vendors that are trying to solve this riddle by employing some kind of, you know, economic function, co-optimization, and kind of so at any given moment of time, give an economic function to whatever battery is available to do and how much energy is left in it.
Thanks, Nick. I think that really the question points to the importance of the controls and dispatch protocols and how it's not enough to just have a battery. I mean, it becomes really obvious very quickly when you start really thinking about what you need the system to do. And typically, you want it to do more than, you don't want it to do just one thing, because in order to get your maximum utility out of the battery, you want it to be available to do numerous things, but then you have to figure out which task is the high priority task, and then how the rest of them fall, in order, descending order after that, and then how do you make those? How does the system know where to dispatch the battery when, and when to, for example, maintain a charged state because it's anticipating needing to discharge versus, wanting to discharge so that it can then be available to charge and so forth. So I know there's a bunch of companies out there that are supplying these controls. Do you guys have, and this is not a listener question, but I'm just kind of inferring this from the previous discussion, do you guys have any suggestions on, when you're going out with an RFP for a system, how do you get what do you do about the controls? Is it a separate RFP? Is it built into you're looking for a battery vendor that's going to provide controls or have a previous arrangement with some kind of company that does this, or have on board, a computer that does it, or how do you actually mesh those things? Do you get two different vendors and then hope they can work together? What do you do?
So Todd, I'm going to jump in. Sorry, Nick, but because you bring up a very important point. So I cannot stress enough, you never want to do separate RFPs. You want to have one RFP, you want to have one owner. Because you will never get two sides to not point fingers at one another. So when you're doing your RFP, that you want a complete system. Complete system. You never want to separate. I'm going to have a control guy over here. I'm going to have a battery guy over here. I'm going to have somebody, even if you add other things. No, you want one stop, one person to be the overall owner, integrator, etc. of that project. And
yes,
and just an answer, a Borneo comment on that whole thing. So Sandia is working on this optimization, right? How do you control a battery to do multiple tasks, given all this variable information? And it can get very, very hard. It can be, and so we're a bunch of scientists here, and so we like hard problems, and we like to be clever, and we like to think of things. But I think there's some people in the industry, and when they get right down to it, you're probably going to be able to capture, and I'm just throwing a number here, 80% of your solution, right, with very minimal control logic, right? The other 20%, maybe the other 10%, it might get really tricky because you're going to have all this price signaling that you're going to look at. You're going to have like weather forecasting you're going to look at, and you're going to take all these inputs and you're going to try to spit out some outputs of how you want your system to operate, right? All these inputs being variables too, right? Now, and so what we're seeing, like working with the utilities, these guys are pretty good. I mean, the guys out there in the utilities, I'm surprised we have electricity, really. And these guys are really good at forecasting. Like, they know when their yearly demand's going to hit. They kind of know this, and they know it a day ahead that, hey, looking at the weather forecast, looking at our pricing signals, or day ahead pricing signals, we kind of know that tomorrow's the day. So I can't hardly remember the question now, but I think the thing to take away from it is we're working on it. There's a lot of bright people working on this optimization scheme, but when you get right down to it and you get into the trenches like Bright Power's doing, it's not going to be, you're going to capture a lot of it with the technology that's there and just some smart programming.
Okay, thank you. Nick, did you want to say a word? We got about 15 minutes left, and I want to try to get to some more questions, but go ahead if you want to.
No, it's fine. Let's move forward.
Okay. Next question is, what's your experience in trying to accomplish various project stages in parallel? For example, permitting process while awaiting delivery of system components.
I don't know that I have that much experience on it myself, so maybe Nick, but I will make one comment. Everything you can do in parallel is better. However, if you have a risk of not getting a permit and you're ordering equipment, you know that is the risk that you have to weigh. Like what happens if you don't get the permit? What are you going to do about the equipment?
Yes, that's correct, and you could arrange it that way. But what I would recommend is that the contractor or the EPC who you're going to work with, who's winning the RFP, should be responsible for these things. So you know the work breakdown structure and the things that could be parallelized, it should be their responsibility. Because yes, in the project that we see right now, obviously the contractor who has a lot of experience getting permits behind their belt, yes, they can manage the multiple permitting processes in parallel while while delivering components, etc. Because they've done a couple of projects in this area and they have a high level of confidence that they're going to get that permit. But I would say that it should be on them to manage that. The owner of the system should care about higher level milestones.
Okay, good. Here's a question from a DOER grant recipient, and I don't, by the way, know if many of these may have been from grant recipients, but they didn't identify themselves as such. This one says, how do we mitigate the uncertainty around the equipment issue, i.e. not knowing which manufacturer a vendor is planning on going with in the RFP? So how do you mitigate the uncertainty in the RFP?
Well, there's probably multiple ways. One way is just ask them, say, hey, you need to have that person on board. And usually what they'll do is they'll give you maybe a list of 2, 3. This is what I've seen. They'll give you, it's either going to be this guy, this guy, or this guy. And so then you can make a judgment on that. Or you can just, your guidance to them might tell them that you need to come with a full project team, and you have to have all these people known and listed.
Yes. So, for example, in the existing RFP of one of the DOER recipients, it has been very clear cut who should be on the project team, what their competence should be, how many years of experience, what certifications, etc., etc. So that risk definitely could be mitigated, especially concerning the utility scale projects. The BTM projects, I wouldn't say you should be that restrictive.
Okay. Somebody has made a comment here. This person says, I think it is important to note that many energy storage systems are a collaborative effort of extremely qualified vendors, i.e. an integrator who is usually the lead, a battery manufacturer, and an inverter manufacturer, for example. These collaborative proposals should not be discounted as they're bringing together a team with a great deal of expertise in their individual areas. I don't know if anybody wants to comment on that. It's just, it's not a question really, but it's a comment.
Yeah, that's a good comment. That's usually how it happens.
Okay. Let's see. There's somebody here who is asking for information on the load reconstitution question that is current in ISO New England and is under discussion. I don't know if we have information on that. Do either of you have that information and know what's going on with that?
Todd, didn't we?
Sorry?
We were just meeting on that not too long ago.
Yeah, we've discussed it, but what I'm asking is whether this person wants to know whether there's anyone on the call has information as to what progress has been made with ISO New England on that issue. So if I don't have that off the top of my head, but to the person asking the question, it is something that we're very interested in. I know there's a lot of concern about it in the New England ISO, and it's something that I believe is being addressed. And I will say that Massachusetts DOER and Massachusetts Clean Energy Center have jointly commissioned an energy storage study that's about to be released. It should be released sometime in the next 2 or 3 weeks. And I know that there is a significant chapter devoted to issues of energy storage market in ISO New England, where Massachusetts is located. And I believe that probably following on this study, and I'm not qualified to say this definitely, but based on what I've heard, I believe that the study will make some recommendations as to proposals or negotiations that could happen with the with ISO New England on addressing some of these, and load reconstitution is certainly one that DOER has heard from, going right back to the initial energy storage stakeholder workshop that was held prior to kicking off this study. So it is certainly an ongoing issue. Probably ought to just leave it at that for now, but it is something that we are looking at, and I know many of you are looking at. Okay, let's see. We've got a few minutes left here. Here's a question. Are there any battery technologies that can address multiple grid issues, such as providing frequency regulation and peak shaving, in other words, power and energy applications?
Short answer is yes. The lithium ion is one of them. The ultra battery lead acid is another one. I'm not quite certain on the flow battery. I keep reading things, but I'm a little bit confused on what their capabilities are for the fast cycling application.
I have read a couple of. I won't tell the vendor, but I have read a couple of studies that some flow batteries now are starting to be able to do fast cycling. And also, there are hybrid systems. There you can put together a hybrid system that contains both, for example, lead acid and lithium ion to do both.
Certainly. Yeah, that's certainly the case. Okay.
Actually, that's what Green Mountain Power is. Green Mountain Power is a hybrid system.
Yeah, that's right. 2 megawatts of lithium ion and 2 megawatts of lead acid. Okay. Question for Dan. Does Sandia provide SW testing certification services for participants in the controls market?
SW means?
I don't know. That's what it says.
Software, maybe?
Probably. They're talking about controls, so that would make sense.
So we don't do certification. We don't do any certification at Sandia. We do testing. So, we could take their system and there's a potential that we could take their system and test it, but we wouldn't certify anything. We're not allowed to do that.
Okay. And along with that, there were some people that were asking if we could recommend, reputable lithium-ion companies. I don't know if we can do that, but is there a resource that anyone who's on the call could look to for independent testing, verification of some of the battery systems that they might be presented with by a bidder?
Well, actually, Sandia does some independent testing of systems. we offer that. Another area up there in the Northeast would be New York Best that has a battery testing facility or energy storage system testing facility, and they could do that. Then who else? Well, there's stuff on the West Coast. MIT might be able to provide some. I know they have some testing facility there at MIT where they're testing some things out. So is that what they're asking?
Yeah, I think this goes along with another question that's a little more general, but along the same lines, and that is, could the presenters suggest some sources of data that would allow RFP developers to, assemble the operating and system specifications, things like meter data, utility reports, above and beyond billing, et cetera. So in general, I think people are looking for sources of data and sources of information. Are there resources that we can recommend?
So that's a good question, and I right off the top of my head, I wouldn't be able to list those, but maybe that might be something that we could do some look into and provide some further information on when we provide this this document that you're talking about providing.
Okay, so we'll take that as as homework to try to include some reference materials, some sources of data, third-party data that could be of help to folks putting together RFPs. As I said, we are developing an information packet. So all of you who are on the call, we will be getting you some information and try to incorporate these questions, as well as a few that I'm afraid we won't have time to get to because we're at the end of our webinar, and we already have spent an hour and a half, and I don't want to take up more time. But I think we got to most of the questions, and I really appreciate everybody's contributions. I think this has been helpful. I hope it's been helpful. I'm going to ask Samantha to maybe just briefly mention a couple of upcoming webinars that we have, and then I think we're going to call it a day. Samantha?
Thanks, Todd. So we do have a webinar coming up tomorrow that may be of interest to the folks on the line. This webinar is featuring guest speakers from Customized Energy Solutions, and they will be presenting on energy storage market updates and focus on modeling for system design. And this webinar is also free. It's at noon Eastern tomorrow. You can find more information on that at CESA.org/webinars. And finally, I'll leave you with some contact info for us and some links for more information. And thank you, everyone, for joining us for this webinar.
Yep. Thanks very much to Dan and Nick for really hanging in and responding to the questions and doing an excellent job. We will, as always, archive the webinar recording, and slides should be up within a day or two. Okay. Thanks, everybody.
Thank you.